So in the previous lecture we talked about the steepness and equated that how steepness and the rate of change are correlated or related to each other. Steeper the graph, faster the rate of change, and so on, so forth. Welcome to lecture 3.2 of module 3 Mathematics 2.0. Herein we are going to look to the steepness, that more steeper the line drawn for the tangent, the faster the rate of change. We are also going to look into that if the steepness is on the positive side, then it is going to be increasing, but if the steepness is in the negative side, it is going to get decreasing. The rate is going to increase by the steepness in the positive side and decrease by the inclination or the steepness or the slope in the negative side. So in the previous lecture we saw that, say for example, this is the time t and this is the distance d, and this is where individual has to reach. Say for example, the individual took this path, this was RQ, this was O. So for this particular point, reaching from O to Q, the time taken was TQ, and the distance would always remain same as D. Then somebody worked or ran faster. He reached to the point Q prime. The time taken to travel the same distance was TQ prime, and this is shorter, means TQ prime is smaller than the TQ. Means this implies that TQ prime, when it is reaching to Q prime, he was faster. So we can very well say that the rate of change purely and surely depends on the steepness of the curve or steepness of the path by which it is stating. It means the steepness for this TQ prime, coverage of Q prime at the level Q prime, is greater than that of for the Q alpha. So when we look to the steepness, there is one very important thing which comes into picture, and that is nothing but slope. Let us understand that what does this slope means. Say for example, there are 2 points P and there is a point Q. Say for example, this point, we know that this is the input side X and this is the output side Y. This P and this Q would have very specific points. This P would have coordinates x1 and this Q would have coordinates x2 in the x-axis, whereas this would have coordinates y1 and this would have coordinates y2 in the y-axis. This is the input. For P, the input is x1 and the output is y1. If we look to the coordinate system out here, now this would have y1 and this would also have the coordinate x1. So the P, this is the coordinate of P, that is nothing but x1 and y1. For the Q, we are going to have the coordinates as x2 and y2 as coordinates. Now if I want to understand that what is the basic slope, we'll have to take that this is the change in y direction, that is delta y, and this here is the change in x direction, that is delta x. The slope would not be nothing but equals to change in the y direction divided by the change in the x direction. In this case, for this particular case, because y2 is greater than, y2 is the second point, that is the Q point, y2 minus y1 divided by x2, because x2 is the later point, x2 minus x1. This is going to be very, very important in terms of rate of change. Now let us look to a scene or a scenario that there is a function which is varying in terms of P and Q, again, this would be the point or the starting point P, and this would be the ending point Q. The P out here would have the coordinates, maybe say the input is A here, and at the Q, let the input be A plus H. Now this is nothing but depicted by H out here. For the output side, because this is going to be the input, and this point over here would be depicted by output of the function at A, and this is going to be depicted as the output of the function at A plus H. Now this is the input A plus H, and this is going to be the output at A plus H. There is a line which is joining these 2 points. In order to find the slope of this line, we are going to find the slope of this line. This would be nothing but output of the function of at A plus H minus the output of the function at A, because this point is nothing but FA, and this point is nothing but depicting FA plus H, and we all very well know that this is the point A plus H and this is the point A. So if I intend to find the slope at or between P and Q of a line joining P and Q, again by the same principle, by the same phenomena, we like to have that it is going to be depicted FA plus H. This is nothing but Y2 out here minus FA. This is the difference in terms of the output. This is the difference of outputs. We very well know that this is nothing but in the y direction divided by the difference, that is nothing but the difference in the input. So the difference in the input is A plus H minus A, that is nothing but H. So this slope, I'll call this as secant, because this slope is depicted by M, and the secant is nothing but the line joining between the curves at point P and Q would be nothing but the outward point, the Q's y coordinate minus P's y coordinate divided by the difference in the x. This is nothing but the slope of secant. Very importantly, if it has to be found that what is the tangent. Now the tangent would be something like this, that this point, this H is actually approaching 0. So the slope of the tangent means, if I graphically depict that the tangent is nothing but at a particular point, the line passing by, the tangent at this point would be given by limit H tending to 0, because this has to come back to this particular point. Limit H tending to 0, again FA plus H minus FA. We know that this is for the Y or for the output side divided by H. Now this is nothing but the slope of tangent. The basic difference is that it has got limit, wherein the difference of the farther point and the closer point is tending to 0. Let us look to a setup like this, in which there is a burner which is heating the water, and we are recording the temperature. This record of the temperature is done with respect to time. Let us see a scenario in which the water is started from the room temperature and went till the boiling. If I look to these 2 points, that is start point at the room temperature and boiling point, there will be an average rate of heating. The rate of change would be average between these 2 points. This is one way of looking to this phenomena. The other way is that what is the instantaneous at that particular point of time? What was the rate of heating, or what was the temperature which was attained or achieved because of this kind of heating? This kind of scenario you'll encounter in your day-to-day life. You'll see them in kitchen while making a cup of tea. You can see it anywhere in terms of time temperature, in terms of distance moved by a vehicle, so on so forth. In the next lecture, we are going to encounter and look into what is the average rate of change and what is the instantaneous rate of change. I'll see you in the next lecture. Thank you.